Welcome to the deep dive.
Glad to be here.
Today, we're jumping into a really core Java topic. It's fundamental for writing solid code, reliable stuff.
Absolutely. And let's face it, crucial for getting through those tech interviews.
Definitely that too. Exception handling.
That's the one. Seems simple, maybe, but the details, that's where the real understanding shows.
Right. So our mission today is basically to unpack all of this. We've got your notes, your insights. We're going to try and turn these technical rules into something clear, something you can actually use.
Yeah, think of it as a bit of a guide. We'll go from the basic why do exceptions even exist, through the whole hierarchy, managing resources safely, which is huge.
And some of those newer API tricks for validation too.
Oh yeah, definitely covering those. It's all about getting you ready to talk about this stuff confidently.
Okay, ready to demystify Java exceptions.
Let's do it.
All right, let's unpack this. So starting right at the beginning, why? Why exceptions? What was wrong with the old ways?
Great place to start. So back in the day, a lot of languages use return codes, special values.
Like you'd get a -1 if something failed.
Yeah.
Or some other magic number.
Exactly. -1, 0, some specific integer, and the caller, the code using that method, had to check every single time.
And if they didn't?
Well, that was the problem. If you forgot, the error just vanished. Silently. The program keeps running, but maybe the state is wrong.
And then boom, something breaks way later, and you have no idea where the real problem started.
Total nightmare to debug. So Java's approach is different. A method doesn't return a magic value for an error. It throws an exception.
It actively signals, stop, problem here.
Precisely. It's like hitting a roadblock. The code says, cannot proceed. Someone else needs to deal with this situation.
And then some other code, maybe further up the call stack, uses a catch block to handle that signal.
Yes. And that's the core benefit. It decouples error detection from error handling. The code that finds the problem doesn't need to know how to fix it.
It just raises the alarm.
Right. The fire alarm analogy is pretty good here. The alarm goes off where the fire is.
But the fire department, the handler could be somewhere else entirely. They just respond to the alarm.
That's it. The throw keyword is pulling the alarm. The catch keyword is the handler arriving.
Okay, so when should my method pull that alarm? When do I throw?
You throw when your method cannot do what it promised. When it can't fulfill its contract, maybe a resource is missing, or very often the input is just wrong. Invalid arguments.
Like that randint method example, generating a random number between bounds.
Yeah, suppose it's randint lower upper. What if someone calls it with randints using 10 and 5? So lower is 10, upper is 5.
That doesn't make sense. The contract is broken.
Right. Trying to guess like, oh, maybe they meant to swap them. That's risky. It might hide a bug in the calling code.
So instead of guessing,
You throw. As the code shows, you'd likely use something like throw new illegal argument exception.
with a helpful message like lower bound cannot be greater than upper bound.
Exactly. Illegal argument exception is the standard choice for bad parameters. It clearly says, you called me wrong.
And importantly, when that throw happens, the method just stops, right? It doesn't return anything.
Correct. Normal execution halts. Control immediately transfers out of that method, up the call stack, searching for a compatible catch block.
This whole when to throw versus return codes thing, that sounds like prime interview fodder.
Oh, absolutely. The key takeaway. Exceptions are for exceptional situations. Things that violate the method's contract, not just normal results like not found if not found is expected sometimes.
Things like missing files, network errors, bad input it wasn't designed for.
Yeah. And a common pitfall interviewers spot is code that tries to fix bad input internally instead of throwing. Don't do that. Throw the exception.
Yeah.
Let the caller handle their mistake.
Okay, so we know why and when. Now, you mentioned this hierarchy, this family tree of exceptions.
I did. It all starts with the throwable class. That's the mood of everything.
Everything throwable inherits from throwable.
Right. And under throwable, there are two main branches, error and exception.
Error sounds bad.
It generally is. Error and its subclasses represent serious problems, usually system-level stuff the application can't realistically recover from. Think out-of-memory error. The JVM is struggling.
So you generally don't try to catch an error.
Nope. They're considered unchecked. You let the system handle it, which usually means the application is going down.
Okay, so error is for catastrophic failures. What about the exception branch?
That's for conditions applications might be able to handle. And this is where we hit that really important distinction. Checked versus unchecked exceptions.
Right, this trips people up. What's the real difference?
It boils down to the compiler. Inside the exception branch, you have runtime exception and all its kids. And then you have everything else.
Okay, so error in runtime exception and its subclasses are unchecked.
Correct. The compiler doesn't force you to deal with them using try-catch or a throws clause.
Why not?
Because they usually signal programming mistakes.
Yeah.
Bugs, things like null pointer exception.
Trying to use a variable that's null.
Or index out of bounds exception.
Accessing an array outside its bounds.
Or class cast exception. These are typically things you should fix in your code, not try to recover from at runtime.
You fix the bug, you don't just catch the symptom.
Exactly. Checked exceptions, on the other hand, are all the other subclasses of exception. Things like IO exception, file not found exception, SQL exception.
And for these, the compiler does get involved.
Yes. The compiler forces you. You must either handle it with a try-catch block, or you must declare that your method might throw it, using the throws keyword in the method signature.
So checked exceptions are for problems you can kind of anticipate. Often external things, like a file might genuinely not be there, or the network might drop.
You got it. They're like those weather warnings you mentioned. Bad weather might happen, so you prepare, you handle it, or declare you're not handling it. Unchecked exceptions are more like find a fundamental flaw in your car's engine. During the trip, it means something was wrong with the car, the code to begin with.
I like that memory aid. Checkable, checked. If it's an external thing you can reasonably foresee,
Like a file not existing.
it's probably checked. If it's a coding error, like using null.
It's probably unchecked. Think about integer.parseInt with some string straight. It throws number format exception, which is unchecked. Why?
Because I could check the string format before calling parseInt. I have control.
Right. But what about class.forName with a string strat? That throws a checked class not found exception.
Because I can't really know for sure if a class with that name exists until I actually try loading it. It's external to my immediate logic.
Exactly. It's an external dependency you can't easily validate beforehand. That distinction is key.
Okay, that makes sense. And if I need a specific kind of error for my application, I can create my own exception class.
Yep. You just extend exception for checked or runtime exception for unchecked. Good practice is to provide a couple of constructors. One with no arguments and one that takes a message string, and maybe one that takes a cause, but we'll get to that.
Right. Now, about declaring those checked exceptions, the throws clause. If my method calls another method that throws IO exception,
Then your method either has to catch that IO exception or it has to declare throws IO exception itself. The compiler enforces this chain of responsibility.
so the signature might look like public void my method, throws IO exception, SQL exception, listing all possibilities.
Exactly. Comma separated. You can list a superclass too, like just IO exception if it covers several specific IO errors you might throw. But big warning here, don't just lazily declare throws exception.
Because it's way too general. It tells the caller nothing useful.
Right. Defeats the purpose of checked exceptions. Be specific. This ties into that throw early, catch late idea. Don't just catch something because the compiler complains if you can't actually handle it there. Let it propagate up to code that can.
Makes sense. Throw it where the problem happens, catch it where you can actually do something about it. What about overriding methods? How does throws work with inheritance?
Ah, good one. Classic interview question. When you override a method, the overriding method in the subclass, it can declare that it throws fewer checked exceptions than the superclass method.
Okay, fewer's fine.
Or it can throw more specific exceptions, subclasses of what the superclass declared.
So if the superclass says throws IO exception, my override can say throws file not found exception. Because file not found exception is an IO exception.
Perfect. But, and this is the key, it cannot declare new or broader checked exceptions. If the superclass only threw file not found exception, your override cannot suddenly say throws IO exception.
And if the superclass method declared no checked exceptions in its throws clause,
then your overriding method cannot throw any checked exceptions, period. Unchecked exceptions are fine, but no checked ones.
compiler enforces that strictly. Got it.
Yeah.
And always document with @throwsinJavadoc.
Please do. Explain why it might be thrown. Helps everyone.
Okay, quick detour. Lambdas. Can they throw checked exceptions?
The Lambda syntax itself doesn't have a throws clause. But if the code inside the Lambda throws a checked exception, then that Lambda can only be used with a functional interface, whose abstract method also declares that same checked exception, or a superclass of it.
So the target functional interface have to allow that exception type in its signature.
Exactly. If you have, say, a processor T interface whose process method declares throws IO exception, then you can pass a Lambda like item-files.write, because files.write throws IO exception.
But if the interface method, like consumer's accept method, doesn't declare throws.
Then your Lambda cannot throw a checked exception directly out. You'd have to catch it inside the Lambda or maybe wrap it in an unchecked exception, if that makes sense in context.
Right. The functional interface contract is king there.
Right.
Okay, let's flip to the other side. Catching exceptions.
Okay, so you've got code that might throw something. You wrap it in a try block.
And immediately after the try?
You put one or more catch blocks. Each catch specifies the type of exception it can handle. Like catch, file not found exception X. That X variable holds the actual exception object.
And I can have multiple catch blocks for different exception types.
Yep.
Handle file not found exception one way, handle a general IO exception another way, maybe handle SQL exception differently again.
But the order matters, right? I remember hearing that.
Critically important. Another interview favorite. You must put the catch blocks for the most specific exception types first.
So catch, file not found exception X, has to come before catch, IO exception X, because file not found exception is more specific.
Exactly. If you put catch IO exception X first, it would catch everything, including file not found exception, and the more specific block would become unreachable code. Compiler error. Specific first, general later.
Got it. Specific first.
And since Java 7, you can use a multi-catch block. Handle several types in one block using the pipe operator.
Ah, like catch, IO exception, SQL exception X.
Right. If the handling logic is identical for both, it saves duplication. The type of that X variable will be the nearest common superclass of all the types you listed. Exception in that case, usually. And remember the anti-pattern. Avoid catching just plain exception unless you absolutely have to and know why. Be specific. Okay, try and catch handle the flow. But resources, files, sockets, database connections, closing them used to be such a headache.
Oh, it was terrible. Resource leaks were everywhere. You'd open a file stream in a try, then maybe an exception happened before your close, call in the finally block.
The file handle just stays open. Leaking resources.
Exactly. Very common, very hard to track down sometimes. This is why try with resources was such a massive improvement in Java 7.
The automatic door closer.
Hey, yeah, that's a good way to put it. It guarantees that resources declared in the try header are closed automatically. Always. Doesn't matter if the block finishes normally or throws an exception.
And the syntax is clean. Right. Try, resource type resource.
Yep. You declare the resource right there in the parentheses after try. The only rule is that the resources class must implement the auto-closable interface.
Which has that close method.
Correct. Or it's sub-interface closable, which is common for IO stuff, and its close method throws IO exception. The JVM just guarantees that close gets called on anything declared in that header when the block exits.
Can I declare multiple resources?
Sure. Separate them with semicolons, just like variable declarations. Try, reader R, writer W.
And they close in reverse order. Last one declared closes first, LIFO.
That's right. Stack order. And one of the huge benefits, especially compared to manual finally blocks, is how it handles exceptions during close. It's called suppressed exceptions.
Suppressed. What does that mean?
Okay, imagine an exception happens inside your main try block code, but then while automatically closing one of your resources, the close method also throws an exception. Which error do you see?
The second one. The one from closing. That seems problematic.
With old finally patterns, yes, that could happen. But try with resources is smarter. The original exception from the try block is considered the primary one. The exception from the close call is suppressed.
So it's not lost.
No, it's attached to the primary exception. You can get it later by calling the getSuppressed method on the main exception. This preserves the root cause and the cleanup problem information. It's brilliant for debugging.
Wow, okay. So try with resources, TWR, is pretty much the standard now for anything auto-closable. Handles cleanup, handles suppressed exceptions. Definitely need to know that for interviews.
Absolutely. TWR equals automatic cleanup. Simple.
So if TWR handles resource cleanup, what's the point of the finally block anymore?
Good question. Finally is still useful for cleanup actions that aren't tied to auto-closable resources. Think about releasing a lock, maybe resetting some application state, things like that. Code in finally runs almost always whether the try completed normally or through an exception that was caught or through an exception that wasn't caught.
Almost always. When wouldn't it run?
Well, if the JVM itself exits, like system.exit, or if the thread gets killed externally in a really harsh way, but generally you can count on finally running.
But I've heard there are traps with finally. Big no-nos.
Oh, yes. Major pitfalls. Number 1. Don't throw exceptions from a finally block if you can possibly avoid it. If an exception was already propagating out of the try or catch, an exception thrown from finally will mask it. It replaces the original one.
So the caller sees the cleanup error, not the actual problem. bad.
Very bad. Even worse, and a huge red flag in interviews. Using control flow statements like return, throw, break, or continue inside finally.
Why is return in finally so terrible?
Because finally executes after try catch, but before the method actually returns or propagates an exception. If your try block calculates a result X and is about to return X, but your finally block contains return Y.
The method returns Y, not X.
Exactly. And worse, if an exception was about to be thrown out of the try or catch, a return in finally just swallows it. Gone. The caller never knows an error occurred.
Okay, that's critically bad. So finally is only for cleanup actions that don't change the outcome or flow. No return, no throw.
You nailed it. Memory aid. Finally is for cleanup only. Trying to change control flow there is almost always wrong. That's also why manual resource closing in finally was tricky if close. Through an exception, it could mask the original one. TWR avoids this with suppression.
Okay, let's say I catch an exception. Maybe I log it, but my method can't really fix the problem. I need to let the caller know.
That's rethrowing. You catch it, do your logging or whatever local action, and then just rethrowing the same exception object up the stack.
And the compiler is smart about figuring out what check types could still come out.
Yep. Since Java 7, it does a pretty good job at analyzing what could actually be rethrown from that block, even if you caught a broader type like exception.
Okay, related concept. Chaining. Catching a low-level error and wrapping it.
Exactly. Exception chaining. You catch something specific, maybe a SQL exception with some obscure vendor code.
But you want your calling layer to just see a generic data access exception or something?
Perfect example. You catch the SQL exception, then you create and throw new data access exception. You pass the original exception as the cause to the constructor of the new higher level exception.
Like forwarding that email, adding your own note, but keeping the original attached.
That's the idea. The caller sees the abstraction, data access exception, but if they need to debug, they can call get cause on it to retrieve the original SQL exception and see the low level details.
What if my custom exception class doesn't have a constructor that takes a cause?
Most well-designed ones do. If not, you can call the initCause method on the new exception once to set the cause manually. But really, you should design your custom exceptions to support chaining via constructors.
And chaining is also the trick for turning a checked exception into an unchecked one if needed, right? Catch checked, wrap in a runtime exception with the original as the cause.
Yes, that's a common pattern when interacting with frameworks or interfaces that don't allow checked exceptions. Memory aid, chain to maintain, wrap to abstract. Always chain if you wrap, don't lose that original cause. Throwing a new exception without the cause is another anti-pattern.
Okay, what if an exception gets thrown and just nobody catches it anywhere up the stack?
That's an uncaught exception. The default behavior is that the thread which threw it prints the exception stack trace to system.err.
Standard error stream.
Right, and then that thread terminates.
And that stack trace, that's the gold mine for debugging, right?
Yeah.
Shows the whole call sequence.
Absolutely essential. Class name, method name, file name, line number for each step leading up to the error. You can also set a default uncaught exception handler for your application using thread.set default uncaught exception handler, which is good for centralized logging or cleanup before shutdown.
And if I have to catch a checked exception, maybe due to an interface, but I truly cannot handle it meaningfully.
At the absolute minimum, log it or print the stack trace using x.printStackTrace. Never, ever have an empty catch block. That's like disabling a smoke detector.
Just swallows the error. Terrible.
Awful. You can also capture the stack trace to a string if you need to log it to a file or database instead of the console.
And for more advanced stuff, there's the Stackwalker API in Java 9 Plus.
Yeah. Stackwalker gives you a more efficient and flexible way to programmatically walk the stack and inspect stack frames compared to older techniques like throwable.getStackTrace. Useful for building diagnostic tools.
Cool. Okay, last major area. Using exceptions for validation, maybe with some standard library helpers.
Yes, the objects utility class. Super handy for parameter validation. It strongly encourages the fail fast principle.
Fail fast.
Meaning, check your inputs right at the start of your method. If they're invalid, throw an exception immediately. Don't let bad data propagate deep into your logic before causing a failure.
Catches the problem at the source. Makes debugging way easier, like that security checkpoint idea.
Exactly. Fail fast, fail clear. The most common one is objects.require non-null.
Checks if an object is null.
Yep. If it is, throws null pointer exception. If not, it just returns the object so you can chain it.
But why use that instead of just letting the code crash later with an NPE if I try to use the null object?
Because the stack trace from objects.require non-null points directly to the line where the null check failed. It tells you this argument was required non-null and it was null right here. A later NPE might happen lines away, making it harder to pinpoint the bad input.
Much clearer error message. And you can pass your own message string too.
You can. Objects.require non-null with the object and a custom message. Very clear.
What about objects.require non-nulls?
That one's slightly different. If the object is non-null, it returns it. If it is null, it returns a default value you provide instead of throwing an exception.
Useful if null just means use the default.
Right. And if calculating that default value is expensive,
use objects.require non-nulls get.
Precisely. That version takes a supplier lambda. The lambda that generates the default value is only called if the object is actually null. It avoids doing potentially expensive work unnecessarily. Using require non-nulls with an expensive operation directly is a common efficiency mistake interviewers might probe on.
Lazy evaluation for the default. Makes sense. And objects.checkIndex for arrayless bounds.
Correct. Objects.checkIndex validates that an index is within the valid range. Throws index out of bounds exception if not. A clean way to do bounds checking up front.
Using these objects methods definitely signals good practice in an interview, right? Shows you care about validation and defensive coding.
Big time. Shows you understand null safety, fail fast, clear error reporting, even lazy evaluation nuances.
Wow. Okay, we've covered a ton of ground. From why exceptions exist, the error versus exception hierarchy, checked versus unchecked.
Throwing, catching, multi-catch, the absolute importance of try with resources.
The dangers of, finally, rethrowing versus chaining, stack traces for debugging.
And finishing up with those objects validation utilities. It's a lot, but it all fits together.
These really aren't just abstract rules, are they? They're vital for writing code that actually works reliably and doesn't fall apart silently. And yeah, for impressing interviewers.
Definitely. Getting these right leads to code that's more robust, way easier to maintain, and much less painful to debug.
So maybe a final thought for everyone listening to take away from this.
Yeah, think about your current project or code you work with. Where could you apply that fail-fast idea more? Are you validating inputs right at the entry points? And look at your catch blocks. Are you catching exceptions just to log them and rethrow, or maybe catching too broadly? Could you apply throw early, catch late better? Just mull that over.
Good challenge. Okay, that wraps up this deep dive into Java exception handling.
Hope it was useful. Hopefully it cleared up some confusion and helps you feel more confident, whether you're coding day to day or prepping for that next interview.
Yeah, absolutely. And if you did find this helpful, please do hit that like button and subscribe to the channel. It genuinely helps us understand what content resonates and helps other developers find these discussions.
And definitely leave comments. What other Java areas are tricky? What topics do you want us to tackle next? Your feedback really drives what we cover.
Thanks so much for joining us on the deep dive. Keep learning, keep coding, and we'll catch you on the next one.